let's say we want to have a system where we group or put words under categories, and we want to do this automatically. We don't want to do this manually. So for example, let's say you want to create a social media application and you want to, let's think about words that could mean very different things in different contexts. So the name of a company, like Apple, right? Apple could mean a fruit. It can also be a company. How we know what it means is depends on the text surrounding it. Or topics or books. If you want to, or web pages, you want to associate web pages by different topics. So this web page is about finance. This web page is about sports. This web page is about football, whatever. How would we go about classifying it when everything we have is a vector of numbers like so? Okay. Let me show you with an example. Let's say we have these three words and they're represented as vectors of distributions. Cosine similarity is about this. I'll show you how we calculate this in a moment. But it is the angle created by these two vectors. The smaller the angle, the closer they are to each other. They have a closer meaning. They're associated with each other. And obviously, the farther they're apart, the less similar they are. This is a very good example. This is a very nice picture. So you can see the cosine similarity of drone, or the angle of drone and helicopter and rocket are closer to each other relative to, goose, eagle, and bee. So if you would take the cosine similarity of drone and eagle, you'd have, what do we call it? Is that an obtuse? It's not an obtuse angle, but it's even less than 45 degrees. Anyway, you'll get a bigger cosine similarity. Anyway, what I'm trying to say is the larger the angle, the less similar they are. So for example, bee and rocket, they're very dissimilar. So what I want to show you is how to produce such a thing.